So how are IP packets delivered? This will be figure 4. So let's say I'm trying to communicate with some node attached to the internet. So suppose we set up a session with some corresponding node. We'll call it a corresponding node. Or CN on the internet. So that's just a fancy way of saying some internet server. So there's some server we want to talk to. In other words, we're trying to download a big file or something. Corresponding node is the location of whatever we're trying to communicate with. So the CN will be over here. CN will be attached to a router, which is attached to the internet. So my home agent is basically a router, and it's attached to the internet. And it's also attached to my home network. So the home network need not exist. It could be just that the home agent is a router sitting in some internet provider's back room, figuring out where exactly I'm located. So remember, the home agent's job is to keep track of both my home network address and my current location, my care of address. And over here, I have my foreign network. And attached to the foreign network, I have the router foreign agent. And within the foreign network, I have, I'm going to call it MN for a mobile node. So what happens here? What happens here is that the home agent keeps track of the home network address. And it also keeps track of the foreign agent where the mobile node is located. So if I'm downloading a file, the packet will be sent from CN through CN's router into the internet. The internet will route it. Now remember, what's going on here, CN is keeping track of my home network address. That's my fixed address. The CN doesn't want to care about the fact that my IP address is changing, and so it will only deal with my home network address. A packet is sent to the home network address up to the home agent. Okay, the home agent figures out that I'm not in the home network, or perhaps the home network doesn't even exist. That it's just a virtual network. However, the home agent knows that there's a foreign agent over here where my device is actually located. So the home agent will then forward that packet through the internet to the foreign agent. And the foreign agent realizes that the mobile node is actually within his responsibility and forwards the packet along.
But don't they have the same IP address?
Which?
So we said the.
Okay, yeah, I committed a bit of sleight of hand there. So the foreign agent has the COA, which I've said is the moving address. So I think I've confused myself a little bit between the address of the mobile node and the address of the foreign agent. So the care of address, let's say, is just the address of the foreign agent, and the foreign agent is then free to use whatever protocol he or she likes to forward that packet along into the foreign network. So you could think of this as an Ethernet or something.
So that means you gotta implement foreign agents everywhere.
That's right. So for instance, it's probably appropriate to think of each cell phone tower having its own foreign agent within it. And as you move from cell to cell, your foreign agent will change.
But somehow the home agent will know where the foreign agent is, right?
Correct. So there's what has to happen is that as I leave a foreign network and enter another foreign network, for one thing, this foreign agent will realize he moved and will send a message back to the home agent saying he's not in my network anymore. And the new foreign agent will say, oh, this guy just entered my network, and will send a message to the home agent saying this guy's now here. Yes.
So just to add a little bit on this, actually it's the mobile network that identifies itself wherever it's attached. So it's if you move into a different foreign network, it will identify itself. Oh, I'm present in this. For example, if you have a GSM chip,
okay.
you have your HPLM in there, the home network address in there, or if you have a specific service like that the service actually maintains your home network information. So it identifies itself, oh, I'm present here, so it actually sends a message, and that's where you get your foreign network address that is needed by.
Yeah, that makes sense. So each individual device will have its own way of allowing you to contact your home agent. I think there was a question in the back over there.
Is how phone calls routed beyond the scope of this? Or my question is, when home network wants to get to the foreign agent, does it have to use the internet again?
It doesn't necessarily need to use the internet, but it's free to. So, I mean, these are, we've said these are both routers with IP addresses, and so therefore it is possible to pass packets from here to there.
But that costs you twice as many IP addresses.
Yes. So if you had a private network, you could avoid that.
So I'm assuming the home network is the provider.
Yes, the home network is not necessarily. So the way the problem is there's sort of a conflict of terminology here. So cell phone users like to think of the home network as like the company they're subscribed with. In other words, Rogers, let's say, and the foreign network or the roaming network as some other company. So in this case, the home network has a different connotation. It's the subnet in which your home net address, IP address is assigned. So the home network, strictly speaking, might not actually exist. There might actually be no corresponding thing you can plug into, and everything in the world is a foreign network as far as you're concerned. So each individual cell tower is then a foreign network in that formulation. Question over here.
Is this inefficient in terms of end-to-end data?
Sure, yeah. You could think of it as inefficient.
Yeah, but probably the foreign agent attached to the home. So one thing, it's also no, but probably.
So, yeah, it's a good question, actually. Is this inefficient? So, I guess to answer the question, is this inefficient, you would have to answer the question, what's the alternative?
The alternative would be if you could switch the IPs, the fixed IP to your new one, and make it mobile, so you have to work that.
Right. So, if we could somehow, okay, I see what you're saying. So, basically what you want is have a guy here, 1.2.3.4, this is the 1.star router, and then he moves over here, and then this becomes the 1.star router.